Our investigation is focused on studying near-field perception action coordination in fine motor tasks. This experiment setup consisted on a 70-inch TV screen that displays the virtual reality environment, a Kinect and the Phantom Omni device. The purpose of the Kinect was to provide more accurate motion parallax cues and optic flow to the user based on their head movements. Moreover, the participants' interpupillary distance was obtained to have a more accurate stereoscopic setup. The Phantom Omni is a 3D input device that enables the user to experience a simulated sense of touch. With this device, we were able to simulate the feeling of touching a virtual object with appropriate contact forces. First, participants were exposed to a training phase in order to get them acquainted on how to use the device and get them accustomed to the mode of haptic and visual feedback they will be receiving on further steps of the experiment. After the training phase, the participant started the testing phase in which he or she was presented with a 3-peg, a 5-peg and a 7-peg scenario in a random order. During the 3-peg scenario, users completed 21 transfers. During the 5-peg scenario, users completed 20 transfers. And during the 7-peg scenario, users completed 21 transfers. All total, this adds up to 62 transfers per participant. Our experiment consisted in a 2x2 design with 4 between subjects conditions. The independent variables were the presence or absence of haptic feedback and stereoscopic viewing. Our dependent variables were time per trail, distance covered by the ring, number of collisions, number of attempts and placement accuracy. After the experiment is completed, the data from the experiment is converted to a file to be read by our replay tool. Our tool plays back the scenario exactly the way the user performed it. From this footage, the tool extracts data such as time, collisions, and probe distance. For further information about the exciting results of our investigation, please read our manuscript.